Hi everyone, in this video we're going to go over another Leetcode question, binary tree level order traversal. Major tech companies like Google, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Given a binary tree, return the level order traversal of its nodes values, an example from left to right, level by level. For example, given binary tree 3, 9, 20, 0, 0, 15, 7. This is the graphical representation of the binary tree. We need to go level by level and print each level's values in a list. So 3 in a list, 9 and 20 in a list, 15 and 7 in a list, and return its level order traversal as a list of lists. So that's the answer. So how are we going to solve this question? We have a bunch of different algorithms we can use. One of them is DFS, depth first search, another one is BFS. And we are going to use BFS in this question, in this video, because it's easy to implement and easy to understand too. So let's get on the whiteboard and try to implement BFS. So we have a tree and we are given the root node. So we need to go level by level and traverse the tree. If you look at this tree, 3 and 20 are connected, 9 and 3 are connected, 15 and 20 are connected, 7 and 20 are connected nodes. But 9 and 20 are not connected. 15 and 7 are not connected. So the nodes in the same level are not connected. So to be able to connect them, we need help of a data structure. And in this case, we are going to use Q data structure to connect these nodes. So we need to implement 3 steps on each of these nodes. First, enqueue the node, then dequeue and print, then enqueue left and right child nodes. Let's start with the root node. So enqueue the root node, then dequeue and print, dequeue and print. Then enqueue left and right child nodes. So enqueue 9 and 20. 9. 20. It's quite difficult to do in this program. But anyway, so again, queues work in FIFO order. That means first in, first out. For example, you are in a bank, you're queuing up in a bank, and you're the first person. If you're the first person in the queue, you will be served first. If you're the last person in the queue, you will be served last. So here it's the same logic. This is the next item, so this will be served next. Dequeue and print. Enqueue left and right child nodes. 9 has no child nodes, so we continue. So we dequeued and printed, and that will be 9. Resize it, yeah. And 20, dequeue and print. Enqueue, dequeue and print. That will be printed now. Enqueue left and right child nodes. Enqueue 15 and 7. So 7 and 15 enqueued. And we continue dequeue and print, because they have no child nodes here. Dequeue and print, and dequeue and print again. So this is level order traversal in nutshell. So it is very basic version of it. It's just for you to understand. When we add the algorithm, it will be a little more complicated, and you get this question in different formats quite often, but if you understand this part, then the rest will be easy to understand as well. Sorry, I forgot to add these as well. So we printed out each level, and our queue is now empty. When the queue is empty, we are done. So let's get to the next page and see the algorithm. So in the algorithm, we are expected to return a list of integer. So first thing, we create list of integer. That's the result that we will return. And if root is null, then we simply return result. Then next we create our queue. Our queue is created. And we add the root node. Now we start the algorithm. Here, while queue is not empty, as long as there's item in the queue, we will do the while loop. Okay? So on each iteration, we create a level. And we check the size of the queue. And our size of the queue is 3. And we will go through the size of the queue. But we store that in a count variable because queue size changes here. So we don't deal with that. To make things not complicated, to make things easy to understand, we keep it in a count variable. We go through the count variable, then dequeue the first item. In this case, queue.poll, that will dequeue the item. Then we created the level on the first iteration here. So we add the node.value. So the node that we dequeued is 3, added to the result. Okay. So check if node.left is null. No. We have a left child and we have a right child too. So we add 9 into the queue. We add 9 into the queue. And we add 20 as well. Oops. So we continue with the process. And finally, we add our level that we created in the level 0. It was the level 0. So we created our list here, and we add that into our result array, list of list array. So result add level. Excuse me. So we continue. Next iteration. Again, we create the level. This time our queue, this is level 1. And this time our count is 2. We have 2 items in the queue. This is dequeued. This is not in the queue. We have 2 items in the queue. So how are we going to do this? We are going through the for loop again for two nodes. First we will dequeue it, then check node.left is null. Node.left, yes, it's null. Check node.right, is it null? In this case, yes, node.right is null as well. And we continue to the next for loop iteration. So we add, in each iteration, after polling, after dequeuing, we add node.value into the level that we create here. This is how we fill our levels, okay? So this is what we do here. And next item is 20. When we queue that poll, it's 20, and level add queue.poll. So these 2 are added into the list here. So check node.left is null. Node.left is 15. That's a subnode here. And note that right is 7. We add it here as well. And we continue, and we add this level to the result. Now we are in the final iteration. We create our level, that is level 2. Now we are doing this level. And our count is again q.size. We pulled all of these, so our q.size is 2. And we start polling again, checking left and right child nodes, and continue with the for loop again. So here, q.poll again, and add that value to the list. So 15 and 7 is added here. And finally, we result that at level is added to this list of integers. And this is not necessary. So we will return this in the answer. And that will be our answer. We traverse the entire tree, our queue is empty, and we returned each level in different lists. So let's see this in the code. Excuse me. So we created our list of lists. If root is null, we always check. If root is null, return. Create the queue, add the root. Do the while loop iterations. If queue is not empty, do the magic. Create your level on each sum. Create the count size, queue size as count. Do the for loop. Add the level to the result. Add each node that value inside into the level on each for loop iteration, and return the result. So that is pretty much it. And this works. So this is pretty much it for this question. I hope it was clear, and sorry, we forgot the time complexity. Excuse me. So we forgot to mention the time and space complexity. In this case, time complexity is O(n) because n is the number of nodes we have. So we must traverse each node a single time. We must touch each node a single time. That's why our time complexity is O(n), and n is the number of nodes. And space complexity is O(n) as well, because our queue will grow and to the n size. So that will be the space complexity of O of n. So I hope it was helpful, and I have more videos coming up. If you subscribe to my channel, and we can meet again in the near future, please don't forget to hit the like button too. Thanks for watching. Goodbye.